Hi students, we're here to review greatest common factor. And so we're gonna review 4 ways of doing greatest common factor. So I'm gonna show you 4 different ways. You can fast forward to the next one if you need to. I'm gonna show you the list method, the ladder method, the double bubble map, and the prime factorization. So we are going to do the factors of 12 and 18. Let's find the factors of 12 and 18. Factors of 12 and 18. So we want to find the ones that can be divided evenly into each number, or the way I like to think of it is what 2 numbers can it multiply by. So I always know that for the 12 I can go 1 times 12. So I'm going to put the 12 way on the other side to give it space. So it's like I'm saying 1 times 12 is 12. And then I think, what else can I do? I can do 2. 2 times something will give me 12. 2 times 6. So I have 2 and 6. 2 and 6 are also factors. And then I keep going up the line. I already did 1, now I do 2, now I'm going to do 3. 3 times what gives me 12? 3 times 4 gives me 12. Okay, so now I have that. And then I keep thinking 4 times 3 gives me 12. Okay, I already have that. 5, nope. And so I see that I have come up with all the factors of 12. So I'm going to do the same thing for the 18. So I start with a 1 and an 18 on the other side. Remember, do that and give it space to fill in all the ones that go in between. So then I go 2 times what gives me 18? 9. So 9 is another factor, 2 is another factor. Then I think of the 3. 3 times what gives me 18? 3 times 6. So 3 times 6 gives me 18. I have a 3 and a 6. And then I think of just anything higher, 4, nope. The highest I can go is 3 times 6, and it gives me 18. So that gives me the factors of 12 and 18. And then I look for the greatest common one, the one that they have in common, that's the biggest. So in this case, if you look, they have in common this, they don't have in common the 4, but they have in common the 6. So the largest one I can think of, the largest one I can think of is the 6 right here. All right, so the greatest common factor, or GCF is 6. That's the greatest common factor for both of them. So that is your list method. And now we're going to do the ladder method. The ladder method, it looks kind of like a ladder and it looks like division as well. So remember, we were looking for the greatest common factor of 12 and 18. So I would write down 12 and 18, but it's gonna look like we are doing a division. It's gonna look like this. Okay, so write it that way, 12 and 18. And so I'm thinking, what do 12 and 18 both divide into? And the easiest one I can think of is a 2. So I'm gonna divide 2 into 12 goes in how many times? 6 times. 2 into 18 goes into how many times? 9. So I have a 6 and a 9. Could it get smaller? Can I make it smaller? Yes, I can. So I'm gonna keep making it smaller. So I'm gonna do another ladder right here. Watch. And this time I'm gonna divide by, what do both 6 and 9 have in common? A 3. So I'm gonna say 3 into 6 how many times? 2. 3 into 9 how many times? 3. So I have gotten it down to the smallest place I can do. So at this time, I can see that the greatest common factor is going to be, let me see, I'm going to use these 2 that I divided by the 2 and the 3. And so what I see as my greatest common factor, or my GCF, is 2 by 3, 2 times 3, which is really 6. So my greatest common factor is 6. So what I've done here is that I divided in the simplest form I could think of, and then I had to divide again, and now I'm down to the smallest I can have it. So the 2 that are dividing are the 2 and the 3. So I say 2 times 3 equals 6, and 6 is my greatest common factor. Okay, so now let's jump into the double bubble map. And again, we're looking for the greatest common factor for 12 and 18. So I'm gonna make bubbles. Fun. Okay, so now I'm going to think of the factors of 12 first, okay? So what makes 12? So 12 times 1 makes 12. And then I'm gonna think of what else makes 12? What about the 2? The 2 times 6. 2 times 6. Does the 3 work? 3 times, let me see, 3 times 4. 3 times 4 makes 12. And then, so I have the 1, the 2, the 3, and does the 6 work? The 6 can work. I put 6 here, 6 times 2 is going to be 12. I'm putting these on this side, the smallest one on this side, because I'm hoping that they have something in common with the 18. So I'm gonna go now to the factors of 18 in the same way that I did the 12, so I'm gonna do the 18. So I say 18 times 1 is 18. And then 2 times what? Times 9. Okay, 2 times 9. And then 3, does 3 work? 3 times 6. If you said times 6, that's correct. 3 times 6 is 18. And then I keep thinking 4, 5, doesn't work. And then the 6 does work. 6 times 3 is 18. Okay? The 6 times 3 equals 18. As a matter of fact, I could just delete it from here because it already exists. It already exists over here. The 6. The 6 and the 3. It makes 18. So now I look for the greatest common factor in this, and I see, as we talked about, that the greatest common factor for both of these is, let me draw it in red, is the 6. That's the biggest one, greatest one that both have in common. So that's the greatest common factor. Okay, so the last method I'm going to show you is the prime factorization. So remember, we started out with a 12 and an 18. And we're trying to find the greatest common factor of these. So what makes 12? What two factors can you think of that make 12? Well, I can say 3 times 4 equals 12. So 3 times 4 equals 12. And then let's make it smaller. Okay? Can the 3 get smaller? Only if you multiply it times 1. So I'm just going to bring down the 3. And then on this side, on the 4, what makes a 4? What factors can we use to make a 4? 2 times 2. So 2 times 2 equals 4. Okay? So now we brought it down to the smallest level. Let's do this one now. The 18. What two factors can I multiply to make 18? 2 times 9. 2 times 9 makes 18. And then the 2, can it get smaller? Only if I multiply times 1. So I'm just going to bring down the 2. But then the 9, can I break it down even more? Yes. I can say 3 times 3. I can say 3 times 3 on that. And so you can see that I can pretty much eliminate the 3 and 3 with the 3 and a 2 with the 2. Okay, so all I'm doing is matching those. I eliminated the 3 and the 3 and the 2 and the 2. And then I see what I have left. You can see that what I have left is this, the 2 and the 3. So I multiply those. 2 times 3 equals 6. So, greatest common factor is going to be 6. Okay? So that is prime factorization. Students, I hope this has helped. I've gone over 4 ways of finding the greatest common factor through prime factorization. We've done the double bubble map. We've done the ladder method. And we have done the list method. As a matter of fact, I didn't write it up there, but I will do it right now for you. List method. All right, I hope this has helped. Bye.